Hey learners, welcome to Mac. So learners, in the last two videos you just saw what is a prefix sum and how to construct it. So if you haven't watched that video, I would recommend just go and watch that video. I will just add that video link in the description, pin in the comment box, and also I will add it in the I button. So now let's proceed. So here is a question based on prefix sum. Given an array of n elements and q queries with LNR, and for each query we have to calculate sum of all elements in the range LNR. LNR is the index of the array. So here is one constant given over here, that L should be less than equals to R and n and q is greater than equals to 1 and less than equals to 10 to the power 5. So now here is an example over here with an array from index 0 to 6. So here is some query, okay. If L is equals to 2 and R is equals to 4, okay. So L is equals to 2, R is equals to 4. So we have to get the sum of all these elements. So what is the sum? 3 plus minus 3 plus 10, it will be 10. Then if here is given 0 to 4, from 0 to 4, okay. Now we have to sum all these elements. So 1 plus 2 plus 3 minus 3 plus 10, it will result in 13. Like similarly we will just can get the sum from index 6 3 to 6, we'll get this 13. So what is the solution for it? So here is one brute force approach for it, and one pseudo code is given over here. So you can just see, have a look over here. Then there is a method with given an array and also query q with two-dimensional array. So we are here getting the length of the q. Now we are entering a loop which will run from 0 to the length of q. So we are taking L and R from the query q, okay. So now we are starting the sum is equals to 0, and then we are running another loop inside this loop, okay. So which will start, this loop will start from j is equals to L to j less than equals to R, and we are just getting the sum of all these elements and we are printing the sum. So now just see over here that this loop in the worst case will run for how many times? N times. So this loop will have order of n time complexity, and now just see over here, this loop, the outer loop, will run for how many times? Or q times. So this loop, the outer loop, will have order of q time complexity. So and this loop is inside this loop, so it will both this time complexity will get multiplied, because for each of the outer loop running, the inner loop will run for n times. So what is the time complexity for it? For this solution, it will be order of qn, and the space complexity will be order of 1. So order of qn is a large time complexity. If the value of q is very large and if the value of n is also very large, then it will result in very large time complexity. So if you can see in the question, it is given that the value of n and q can go up to 10 to the power 5. So now just see that if n is equals to 10 to the power 5 and q is equals to 10 to the power 5, then what will happen? So you see that generally 1 gigahertz processor runs for 10 to the power 9 time complexity in 1 second. So 10 to the power 9 time complexity will run in 1 second, and this 10 to the power 5 into 10 to the power 5 will result in 10 to the power 10, and when you divide 10 to the power 10 by 10 to the power 9 time complexity, you will result in 10 seconds. So 10 seconds is a large time complexity, this is time taking, and in some case if the size of the time complexity increases to 10 to the power 12, such as suppose, So it will take 1000 seconds. So you can see if the size is increasing, the time complexity is also increasing in great quantity. So we have to optimize the solution. So if you know the optimized solution for it, just comment in the comment box, and then now just proceed. Okay, so here is an optimized solution for that. So in this problem we can use the prefix sum to reduce the time complexity. So you can see this is the same method over here, and now we are calculating the prefix sum over here. We are assigning the element of 0th index in array to the 0th index in prefix sum, and we are just calculating the prefix sum over here, and it will take order of n time complexity. Okay, now just proceed. Now you are taking the length of q query, and we are running the loop from 0 to the length of the query. Here we are taking L and R. Now we are checking that if L equals to 0, just printing the prefix sum of the rth index. Else if you are printing by taking the value of the rth index of the prefix sum and subtracting it from the prefix sum of ln minus 1 index. So in the last video we have seen this formula. Okay, so now what is the time complexity? So the time complexity for it will be what? If this this loop is taking order of n time complexity, and this is taking order of q time complexity, and both these loop are independent of each other. No loop is inside any other loop. So we will just add the term complexity. So what will the final term complexity? It will be order of n plus q. So even if the size of n is 10 to the power 5 and size of q is 10 to the power 5, then it will result in what? 2 into 10 to the power 5. So it is very less than the previous one of 10 to the power 10. So we have reduced the time complexity by a lot, but also the space complexity is increasing. So we can also reduce the space complexity if we just use this array only for making the prefix sum instead of creating another prefix sum with size n. So with this we can also reduce the space complexity. So learners, this is it for this video. If you like this video, just click the like button and do subscribe to our channel. We will be coming with more data structure videos, and also in the next video we will coming with a problem based on equilibrium index. And do comment out in the comment box whatever you liked. If you need to improve anything, just give us a feedback. This will help us in improving our teaching lecture, and hit the bell icon. Thank you.